In this lesson, we're going to learn to convert between moles and the number of molecules or formula units of a compound, and also to see how we use subscripts to determine the number of atoms or ions. In previous lessons, we've looked at the conversions between grams and moles to grams, as well as moles and molecules or molecules to moles. Now we're going to bring those things together and see how we get from grams to molecules or even to atoms in a molecule, or if we're starting with an atom, how we can get from grams to atoms. Just a reminder, the relationship between grams and moles is through molar mass, which is units of grams per mole. Between moles and molecules is Avogadro's number, or 6.022 times 10 to the 23rd things per 1 mole of things. Between molecules and atom, it's the ratio from the chemical formula. And if we're just looking at atoms, we can also get between grams and moles with molar mass. The difference for atoms, so single atoms by themselves, is we can go directly from moles to atoms. We don't have to have the intermediate step of molecules. And we can do that using Avogadro's number. So 1 mole of things equals 6.022 times 10 to the 23rd of those things. How many molecules are in 50 grams of H2O, which has a molar mass of 18.01 grams per mole? You might notice slightly different values for molar masses, and this is just as a result of different rounding on intermediate steps. A difference of 0.01 in a molar mass is not going to change your answer significantly. We know 50 grams of H2O, and that's a simple unit, and we're trying to get to a simple unit molecules. So we're going to start with the 50 grams. I know grams needs to go on the bottom of the next step, so I'm going to put in my molar mass because that's the only thing I know that relates grams to moles. Now, I can put in my value, 18.10 grams per mole, and cancel out grams. Now that mole is in the numerator, I need mole in the denominator of the next step. And the relationship I know using moles is between moles and molecules with Avogadro's number. So I can have moles on the bottom, so they'll cancel out, molecules on top, and then I can put in the numerical value of 6.022 times 10 to the 23rd molecules per 1 mole. Moles will cancel out, and I can do the math and get my answer of 1.67 times 10 to the 24th molecules. A common mistake that students make is putting 6.022 times 10 to the 23rd moles equal to 1 molecule, and this is not correct. We would never say 12 dozen equals 1 cookie. That doesn't make sense because 1 dozen is 12 cookies in the same way that 1 mole is 6.022 times 10 to the 23rd molecules. How many molecules are in 0.0643 grams of water? We're going to start with the 0.0643 grams of water. Next, we're going to put grams on the bottom and moles on top using our molar mass. That's the only relationship we know with grams. We can put the values in there. At this point, grams will cancel out and we have moles. Moles will need to go on the bottom of the next step and molecules will go on top. That's the only other relationship we know is between moles and molecules using Avogadro's number. So that's what we have to use. Moles will cancel out. We're left with units of molecules, and I can do the calculation and find 2.15 times 10 to the 21st molecules. How many atoms are in 50 grams of water? This problem is a little bit different. We're still dealing with molecules, but it's asking for atoms. We only have one number to start with. We want to end with the simple unit, so we need to start with the simple unit. We can't start with the molar mass because it's a relationship. Thinking back to the diagram we looked at earlier, we're going to start with grams. Then we're going to convert to moles. From moles, we can find molecules. And then from molecules, we can find atoms. We start our problem with 50 grams of water. We put grams and moles in the next step with grams on the bottom so the units will cancel out. We use the molar mass in that step. Grams will cancel out. Now we need moles in the denominator of the next step, and the only relationship we know with moles is moles to molecules. And we put in Avogadro's number. 6.022 times 10 to the 23rd molecules is equal to 1 mole. Moles cancel out. And now we need to go one more step than we have previously. We have our molecules and we need to get to atoms. We know that molecule needs to be in the denominator, and therefore we're going to put atoms in the numerator, because for every one molecule of H2O, we have 3 atoms. We can imagine if we took that water molecule and broke it into its individual atoms, we have 2 hydrogens and 1 oxygen. We're going to break that apart, so we get 3 atoms for every molecule of water. Now we can cancel out molecules, and we're left with units of atoms. We take 50 grams times 6.022 times 10 to the 23rd divided by 18.01 and get 5.02 times 10 to the 24th atoms. Make sure it has a unit, just like we want to include units in all of our steps of our dimensional analysis. We also want to make sure we have units for our answer. How many atoms of hydrogen are in 25 grams of CH4? In the previous problem we looked at the number of atoms total in a mass of water. Here we're looking specifically at the atoms of hydrogen. Looking at our diagram from before, we're going to start with grams, convert to moles using molar mass, using Avogadro's number to get to molecules, and then using the ratio from the chemical formula to get to atoms of hydrogen. We start with 25 grams of CH4. We know we need grams on the bottom. The only relationship we know with grams is the molar mass, so moles will go on top. We can put in the numerical value. Our molar mass for CH4 is 16.04 grams per mole. I need moles on the bottom of the next step so that the units will cancel out. The only relationship I know here with moles is Avogadro's number. So 1 mole is equal to 6.022 times 10 to the 23rd molecules. Moles will cancel out. Now I can put molecules on the bottom, and I'm putting atoms of hydrogen on top. For 1 molecule, I will have 4 atoms of hydrogen. This problem is specifying atoms of hydrogen, so we're not counting the total number of atoms, we're only counting the atoms of hydrogen. 1 molecule has 4 atoms of hydrogen. Molecules cancel out. Now I can do the calculation of 25 grams times 6.022 times 10 to the 23rd times 4 divided by 16.04. And we get 3.75 times 10 to the 24th atoms of hydrogen. Notice that I labeled that as atoms of hydrogen and not just atoms. I need to be specific as to what I'm talking about. What mass of CaCl2 would contain 25 grams of chlorine? This problem is a little bit different because we're given the mass of one of the elements and we've got to get back to the mass of the calcium chloride. We're trying to find a simple unit. We're trying to find the mass of calcium chloride. The only number we know that is a simple unit is the 25 grams of chlorine. The molar masses are both relationships, so we don't want to start the problem with those. We start with our grams of chlorine, and then we can convert to moles of chlorine using our molar mass. Just like we did a relationship between molecules and atoms, we can also do a relationship between moles of chlorine and moles of calcium chloride. Because remember, those are the same relationships, just on different scales. For moles of chlorine, we can get to moles of calcium chloride using those subscripts in the chemical formula, and then we can find the grams of calcium chloride. What you're going to find as you're working through problems is that not every problem is going to follow the exact same process. The goal is to get a toolbox that helps you get between different sets of units to get from what you know to what you want to find. And there are going to be times when you make mistakes. You're not always going to get it right on the first time. That's okay. Try it. If it doesn't work, mark it out. Try something else. Writing down your units is going to help immensely with this. Notice on these units, I'll have grams of chlorine, moles of CaCl2, and grams of CaCl2. Because we're dealing with 2 different substances, I need to make sure I indicate that to make sure I'm canceling out things that can actually cancel out with one another. To start our problem, we'll have the 25 grams of chlorine, and I'm going to use the molar mass of chlorine to get 2 moles of chlorine. Grams needs to go on the bottom, and moles goes on top, and that's grams of chlorine and moles of chlorine. I need to make sure I use the correct molar mass of 35.45 grams per mole because I'm dealing with just the chlorine at this point. For the next step, I need moles of chlorine on the bottom because I need that to cancel out with the moles of chlorine in the numerator of the previous step. So I have moles of chlorine, and I can relate that using the subscripts to moles of CaCl2. I can write that relationship based on that formula. I know that 1 mole of CaCl2 has 2 moles of chlorine because of the subscript numbers. Next, I can cancel out my moles of chlorine. Notice I'm canceling out moles of chlorine with moles of chlorine. I cannot cancel out moles of chlorine with moles of CaCl2. Now I have moles of CaCl2 in my numerator, so I need moles of CaCl2 in my denominator of the next step. So I have grams of CaCl2 over moles of CaCl2 because that's the relationship I know involving moles of CaCl2. I put in the 110.98 over 1, and I can cancel out moles of CaCl2, and I'm left with units of grams of CaCl2. So 25 times 110.98 divided by 35.45 divided by 2. Notice we weren't talking about molecules or atoms, so I did not need to use Avogadro's number here. We only use Avogadro's number when we're dealing with molecules and atoms. We use molar mass to get between grams and moles. And what we find is we get 39.1 grams of CaCl2. Again, I have grams for the mass as well as the substance CaCl2.